Now in this video, we will go to take up one more problem. The top view capital PQ of a straight line is 70 mm and makes an angle of 60 degree with XY line. The NQ is 10 mm in front of VP and 30 mm above HP. The difference between the distances of capital P and Q above HP is 45 mm. Draw the projections, determine its true length and true inclinations with HP and VP. So now I want to solve this problem. I want to analyze this problem in 3D and also how to write the sketch by using the graph book or the sketchbook. So here the point capital Q is in front of VP by 10 mm and above HP by 30 mm. So how to consider that? So we have the horizontal plane and you have the vertical plane. As we see, the point capital Q is above HP by 30 mm. Where you can see the distance, that distance can be seen in the vertical plane. So you can see that it is a vertical plane. And it is in front of VP by 10 mm. So when you look from the top view, you can see that distance in front of VP by 50 mm, 10 mm. So you mark this point as small q and you mark this as capital Q and this as Q dash and Q. And then he said the top view of the line makes an angle of 60 degree with XY line is being 70 mm. Since it is the top view, so obviously that image will be seen in the horizontal plane. So from Q, you measure an angle of 60 degrees and you draw a line, inclined line. And then by using the compass from Q, you cut an arc on the 70 mm line, 60 degree line. You mark that point as 70. So then you have the locus of B in the top view. And also he has given the differences between the distances of capital P and capital Q is 45 mm. So here, what is the difference? So that means above HP by 45 means what? It is on the vertical plane when you look from the front view. So the difference means from here to Q dash is 30 and from here if you take the locus of P then it becomes 75. Then otherwise 75 minus 30 will go to give you 45, so that is the locus of P in the front view. So now you got the locus of P in the front view and also you got the locus of P in the top view, and one end of the line has been given with 30 mm above HP and 10 mm in front of VP. So this is how you will be able to take the initial setup in 3D, and the same thing I need to transfer it onto 2 dimensions. So how to do that? First I will go to draw the XY line and you mark VP and HP. So VP will be above XY line and HP will be below XY line. So from XY line you measure 30 mm and draw a horizontal line parallel to XY in the front view. Because it is 30 mm above HP is seen in the vertical plane. Since vertical plane is above XY line, so from here you take 30 mm and draw a horizontal line. Similarly, in front of VP is seen in HP. So from XY line you measure 10 mm below the XY line and you draw a horizontal line. So consider any point on this horizontal projector and draw a vertical projector from that till to the locus of Q in the top view. So once you get this point, you mark this point as Q dash and you mark this point as capital Q, you mark this point as small q and you mark this as capital Q. Then he said the top view of the line makes an angle of 60 degree with 60 degree with XY line being 70 mm. So by using the protractor with Q as center with respect to the horizontal, you measure 60 degrees and draw an inclined line. Then by using the compass with Q as center, measure the radius of 70 and cut an arc on that 60 degree line. And now you are going to get small p. And once you get small p and small q, that is actually the actual drawing. So you join between these two with a dark line. Once you do that, the differences in distances of P and Q above HP is 45. So that means the difference between the locus of P in the front view and the locus of Q in the front view. So the difference between these two is 45. So that means from XY line to locus of Q is 30 plus 45. That means the locus of P with respect to the XY line will be 75. So the difference between both P and Q is 45. Means 75 minus 30 will going to give you the 45. So this is how you will be able to get the locus of P in the front view and you have the locus of Q in the top view. So The next thing is, as we know that you have the locus of P in the front view and you know the locus of P in the top view, and also the top view distance is known. So the distance between the end projectors will going to always cut the locus in both in the front view as well as in the top view. But since you are already having the top view, then from here you draw a vertical projector till to the XY line, and from there you are increasing that vertical projector to the locus of P in the front view. So you got the locus of P, you have got the P dash, and you mark that point as P dash, and here this will going to be Q only. So then once you get the front view and top view here, so through Q you will going to draw a line in space. So you got capital P. So here the entire distance will going to be how much? It is 75 with respect to HP, and this distance of course is from here to here, which is the locus of P. So once you do that, so you are going to get the line in space. Okay. Now how to do that here? So as we know, this is the horizontal line what we got. We have the locus of P in the front view and you have the locus of P in the top view. So once from P you draw a vertical projector such that it will go to catch the locus of P in the front view. So you mark this point as P dash and then join P dash Q dash with a dark line. So that is what we have done. When you look from the front view, P is projected onto the locus of P, so you got P dash, and then join between P dash and Q dash, which will going to be the front view, and this will going to be the locus of P. So once you get this, now we need to find out what is the true length in the front view and also the true length in the top view. So how to do that? So once you do this, so what I am doing is I am trying to find out the true length in the vertical plane. How to do that? With Q as center, taking the radius of QP in the space, rotate that point P such that both Q and P will going to be in front of VP by 10 mm. So that means we are rotating this with respect to VP only. Q is in front of VP by 10, so capital P1 should also be in front of VP by 10 mm. So then only the line will going to become the parallel to VP. Since the line is parallel to VP, so in VP you are getting the true length. So as you look from the front view, P1 is here, P1 dash will going to be projected. Since this is the true length line for this top view line, so naturally this will going to be capital P and this will going to be capital Q. So this is the angle theta. So how you are able to get, this is actually in 3 dimensions. But when you are doing it on paper, what happens, as with respect to Q, by holding the Q, you are rotating the P in space. What happens to the corresponding image? So you can see this is the corresponding image, which is the projector line, which is above HP, which is the same distance as above HP here. So how to do that? So as you are rotating the line in space in the counterclockwise direction, obviously the image in the horizontal plane, that is by looking from the top view, is also being getting rotated such that both Q and P1 is parallel to XY line in the top view. Since in the top view line is parallel to XY, correspondingly in the front view that line will be in true length. That means capital P1 and Q both are in front of VP by same distance, which is 10. So once you get this point, join P1 dash and Q dash, then you are going to get the true inclination with respect to HP theta. Now how to do that? By using the manual sketch now. How to do that now? So here we have the front view and we have the top view. Okay. Now what I want to find the true length in the front view. How to find out the true length in the front view? So to find the true length in the front view, you have to take the top view line. So which is the top view line? That is QP. With Q as center, taking the radius of QP, you draw an arc such that P1 will also be in line with the line of Q. So therefore, P1Q will be the line which is parallel to XY in the top view. Correspondingly in the front view, you are going to get the true length. So from here, you draw a vertical projector such that it will going to cut the locus of P in the front view. Then you mark this point as P1 dash. As we know that the top view line is parallel to XY, its corresponding front view will going to be in true length. So once you get this point, so you mark this point as P1 dash because this distance is, this point is P1, and you make it as capital P because this line will be in true length. So then you are going to get the locus of P in the front view. So once we are able to find the true length in the vertical plane, so that is what we have shown, the true length in the vertical plane, which is the one which is being getting rotated. With Q as center to QP as the radius, you are rotating that such that P1 is also in front of VP by 10 mm. Now this line is in space actually. But since as we are rotating that, what happens to the image also? Image in the, as we look from the top view, the image is also being getting rotated. So you mark this point as P1. So QP1 is parallel to XY. Its corresponding line in this will going to be in true length. As we look from the front view, this P1Q is image is falling on the vertical plane, which is P1 dash and Q dash. So this is capital Q and this is capital P, because that is the true length in the vertical plane. Now, once you get that, how to do that now? So here, now we need to find the true length in the top view. How to do that? So here, you know that this is the line which is in space. With Q as center, taking the radius of QP, you rotate such that both P, this point P and Q are above HP by 30 mm. So actually the P is above HP by this distance. What is the distance? Which will go to be 75. So now what I need to do now? I need to rotate P by holding the point Q, because P should also be above HP by 30 mm. Then only the line will going to become parallel. To which line? This line will going to become parallel. It is parallel to HP. Since it is parallel to HP, how you are telling that it is the parallel to HP? When you are looking from the front view, you can see the distance above HP by 30, and you can also see the distance here also above HP by 30. Now the line is parallel to HP. So that is capital P2Q is the line in space which is parallel to HP. So when you look from the top view, this line is being projected here and this point is also being projected here. So you are going to get Q, and in this case you are going to get P2. Then join Q and P2, which is the true inclination line with respect to VP. So since it is parallel to HP, so you are getting the true length in HP. So you mark this point as capital P and capital Q. So when you are doing like this in space, what happens to the image? The image is also being getting rotated. So with Q dash as center, taking the radius of Q dash P dash, you are rotating that both Q dash and P2 dash are above HP by 30. Obviously, that is the line which is parallel to XY in the top view, in the front view. Correspondingly, in the top view, you are getting the true length. So you mark that point as capital P and capital Q. So how to do this in manually now? So with Q dash, now I want to find out the true length in the top view. Since you want to find out the true length in the top view, obviously you should take the front view line. So which is the front view line? P dash and Q dash is the front view line. So with Q dash as center, taking the radius of Q dash P dash by using the compass, you are rotating such that you are making Q dash and P2 dash both are above HP by 30 mm. Now the line is parallel to HP. So since it is line is parallel to HP, so you are getting the true length in the horizontal plane. So that means in the top view. So draw a vertical projector from here till to the locus of P in the top view and mark that point as P2. So since this line is parallel to XY in the front view, obviously in the top view that line will be in true length. So you mark that point as capital Q and you mark this point as capital P. Then find out the true length. So this is how you will be able to create the drawing. So now I need to check measure the distance from P1 dash to Q dash, which is the true length line, which is 83.22 mm. So in a computer, but when you are doing it manually, it will be getting around 83. Similarly, true inclination with respect to HP, which is theta, is 32.74 here. So it should be 33 degrees. Similarly, true inclination with respect to VP is 5. It is 45.76. You will going to get it as 46 degrees when you are doing it in manual. So this is how you will be able to analyze the drawing in 3 dimensions, and also you should be able to write the sketch by using the sketchbook. So Now finally when you want to measure the drawings, so here the true length will be 83 and theta will be 33 and phi will be equal to 46 degrees. So this is how you will be able to analyze the drawing and also write the solution on the sketchbook. How to say whether our drawing is right or wrong? So here you know this is the front view because its corresponding top view is inclined. You know this is the top view PQ because its corresponding front view P dash Q dash is inclined. You know that this is the true length in the vertical plane. That means in the front view this line is in true length. Obviously in the top view that line will going to be parallel to XY. So this is Q dash and P1 dash. Here it is Q and P. Similarly, I want to know here, this is the true length in the horizontal plane, that is the top view. So its front view line, which is the front view line, P dash Q dash is parallel to HP, that is Q dash P2. And projected, you are going to get P2, join Q P2, so you are going to get the true length in the horizontal plane. So this is how, since it is satisfying all the conditions and hence my problem is right. Thank you.